So to recap what we talked about in the last video, we talked about how cybersecurity could be incorporated into computer science classrooms. I feel like this is a natural application for most of the school districts, is what most school districts try to be doing, incorporating cybersecurity and computer science. But I also want to talk about how cybersecurity could be incorporated into other subjects as well, such as art, economics, psychology, math, and so on. So to begin with, cybersecurity and math, and again, this application might be a bit more intuitive, but first there is the field of cryptography, which heavily relies on math. Um, so there, in cryptography, you deal with modular arithmetic. We saw this in the Caesar cipher. So if you don't remember this, feel free to go back to the first video where we talk about Caesar cipher and how you use modulus to shift the plain text, apply modulus so you wrap around the alphabet, and then get a encrypted ciphertext. So there is the modular arithmetic that is being used. It is also used in the RSA. Caesar cipher is not used in practice today because it's unsecure, but RSA is still being used. It is a public key cryptography algorithm. I'm not going to dive into detail about what this is, but if this is something that interests you, please check out our cryptography workshop that will likely be in May 2024. So there is so yeah, modular arithmetic is also used in industry standard cryptography and widely used cryptography today, such as the RSA. It also heavily builds upon number theory. For example, RSA uses two large prime numbers. So this could be something that you could introduce when talking about prime numbers. People could be like, why do we care about prime numbers? But there is a practical application for prime numbers that I didn't know until I came to grad school. There's also the field of algebra. Cryptography really builds upon abstract algebra and linear algebra. These are more advanced topics that you won't really get into in your K-12 classrooms, but it could get students interested when you talk about algebra, what the potential for it is in later in their careers and studies. And encryption algorithms often use hard mathematical problems. For example, there is the elliptical curve cryptography, or the ECC. So if you're ever talking about elliptical curves, I think this could be a cool example to bring up. There are more applications such as proof of work is something that the Bitcoin utilizes, but it's how you verify blockchain transactions by solving computationally challenging mathematical puzzles. So I feel like all these are good examples to get students interested in math and seeing practical applications for math in cybersecurity. Another area that you can bring cybersecurity into is statistics. For example, AP Statistics Unit 1 explores one variable data. And when talking about distribution and how values are distributed for a field, you can talk about the frequency analysis that I mentioned in Caesar cipher. Frequency analysis is used to break classical ciphers by looking at the distributions of English letters frequency. So this is an example of a graph that you'll see. So this is an example of a graph of a frequency distribution graph. And I'm sure it matches your expectations. E appears a lot in the English language. T, A also appears a lot. You don't see a lot of X, Q, J, and so on. So this shows the distribution of the English letters frequency. So this is something that you can talk about. You can also talk about outliers. Outliers differ significantly from other observations by being very high or low values. And this is actually very useful for analyzing network traffic, because when analyzing network traffic, we need to think about what constitutes a normal network traffic. For example, what is the mean median traffic that we get? Maybe we could have a plot of average network traffic across the time of day. It could look like something like this. across the time of day. But then how do we find outliers? What do outliers tell you? For example, if we get a traffic like this would be an outlier. This might be something suspicious happening. For example, if you remember our cybersecurity computer science lecture, and if you remember the DDoS and the DOS conversation, we actually saw a similar graph to this in the Google's DDoS attack, in the network attack. So this could imply that there is a DDoS attack going on, a DOS attack going on, or other malicious anomaly activities. So looking at outliers can identify potential DOS attacks or malicious activities. So it will be interesting to bring up and maybe even perform an exercise by looking at mean, median, average like network traffic, plotting it out, and also looking at outliers and how we can find outliers. I guess a more advanced application of statistics, cybersecurity, math would be machine learning. There are a lot of areas of cybersecurity now that use machine learning, for example, to classify different network attacks, and so on. So, and classify malware. So machine learning techniques are being used, but I don't think you'll go into detail, so I also won't go into detail, but I just want to point out that this is also a rising application field when it comes to cybersecurity, math, and statistics. So cybersecurity can also be incorporated into government classrooms and politics classes. So some relevant subjects I could think of are AP US Government and Politics, AP Comparative Government and Politics, World Politics, and so on. But cybersecurity is critical to civil rights. What rights do we have in the cyber world from against cyber attacks? It's also critical to election security. How does cybersecurity of elections and misinformation, disinformation affect democracy? Cyber information warfare is an example. For example, Russia, Ukraine, and the conflict that's going on, there's been espionage, misinformation, disinformation, malware, disruption. So the warfare has been moving more and more to the cyberspace as well. There are also attacks on power grid, supply chain, websites, and more. So we can think about how the concept of warfare and fighting and international conflicts are changing nowadays. If this is something that interests you, we will be holding a cyber law and ethics workshop likely in March 2024, so please come back for that. So now I'll dive into cybersecurity and economics. This is something that personally interests me a lot because I was a economics double major in my undergrad. So in the AP microeconomics curriculum, while talking about the supply and demand, in the cybersecurity labor market, there is the frequent talk about shortage. There is a workforce shortage. There is a cybersecurity talent shortage. So we often talk about how there is a shortage in the cybersecurity labor market. And what does this actually mean in economic terms? So you can, while explaining the supply and demand graph, you can show them what shortage means, and what are some economic policies that try to address this, and what are the short-term and the long-term effect of such economic policies. For example, if we decide to raise the base salary of cybersecurity workers, what would that look like? What would be the short-term and the long-term effects? How would that change the supply-demand model, if at all? So these are all interesting areas I thought would be interesting topics to include in the supply and demand unit. This is a screenshot from Google search so that you know that cybersecurity labor market shortage isn't something that I'm talking about, it's something that everyone is kind of talking about. In the unit 4, imperfect competition unit for microeconomics, you can also include cybersecurity examples for game theory. As you're probably aware, game theory models strategic interactions among rational agents, for example, the prisoner's dilemma. And there are actually really good cyber examples to give. For example, cyber attack and defense scenario. when would people decide to attack? When would people decide to defend? What are the strategic interactions among the attackers, defenders, considered rational agents? And what economic policy could there be? So game theory is another interesting topic that you could dive into and give cyber examples about. Unit 6 deals with market failure and government, and one of the topics here is externalities, the indirect cost or benefit to an uninvolved third party that arises as an effect of another party or party's activity. So you know how you talk about positive externality, something that increases the well-being of others, such as public libraries and museums, and the negative externality, such as air pollution. And cyber examples could be if security of websites is increased, like all websites decide to use HTTPS instead of the insecure HTTP, this would be a positive externality. Users aren't like uninvolved third parties would also benefit from this increased security in websites versus decreased security would be a produce negative externality. Um, Spam phishing emails obviously create negative externalities for uninvolved third parties as it makes us go through unnecessary time and effort identifying the spam emails. Sometimes they're misclassified. So this is a negative externality. And we can even think about what are some economic policies that try to combat these externalities, because positive or negative is still considered a market failure. Another interesting topic that you could introduce is in AP macroeconomics. When you talk about the financial sector, you could introduce cryptocurrencies, which are digital currencies such as Bitcoin that is used as an alternative payment method or speculative investment and so on. Cryptocurrencies are so interesting because it is decentralized. So you talk about the banking system in macroeconomics, but cryptocurrencies don't have a central bank. It utilizes the blockchain, so there is still record keeping. Blockchain is a public and distributed ledger that people have copies of. So there is the concept of record keeping. There is a huge debate about what cryptocurrencies even are. Is it a currency, as you see from the name cryptocurrency? Can we actually call it a currency? Is it a financial asset or investment, commodity, payment network? So even discussing with students about what does currency mean? What does money mean? It could be very interesting. There are also very interesting cryptocurrency applications such as non-fungible tokens, NFTs, which we'll discuss in the arts section, as well as smart contracts. So these could be interesting to bring up. I think a common misconception about cryptocurrencies is that it is anonymous, but it's actually not, because as we discussed, every record, every transaction is stored in a public and distributed ledger. But it is less easier to identify the identity of transactions. So it is more used, like there has been usage of cryptocurrencies by cyber criminals on the dark net, such as Silk Road, which is something that you could introduce students to if you ever end up talking about the dark web or the dark web marketplaces. I think another interesting thing to bring up is regulations. Cryptocurrency regulations differ around the world. What are the pros and cons to such regulations? Should we regulate cryptocurrencies in the first place? And also relating this back to cybersecurity, cryptocurrencies are still very vulnerable to attacks. There can be attacks on the blockchain itself, such as the 51% attack and the double spending problem. There can also be attack on crypto exchanges, websites that exchange cryptocurrencies, utilize like exploiting the web vulnerabilities such as cross-site scripting and social engineering. If you're interested in these, we'll probably have a web exploitation workshop sometime in the future. So please come back for that. And I again think this is super interesting application, cybersecurity and the arts. So one application is the field of steganography, and this is a technique of hiding data within an ordinary file or message to avoid detection. So for example, you would hide a secret message in an image or audio file. I thought this was really cool when I first learned about it. So there is image steganography, you see this nice tree image, but in it actually is a hidden cat image. There are ways to go, like there are complex ways to go about this, looking at the RGB, the pixel values, and looking at like the least significant bits and so on. I'm not going to go into detail, but I think even the fact that it exists is pretty interesting. And there are automated tools that help us discover such hidden images or messages nowadays. This is an example of audio steganography. So for example, Wikipedia, the image was turned into an audio file. And you can put this audio file into something called the spectrogram and be able to identify the hidden image within the audio file. So on picoCTF's platform, actually, there are actually two, probably more, picoCTF challenges regarding steganography. These are pretty simple challenges, and you can use online tools to help you. I would definitely recommend checking it out if you want to bring it up in your class. I think another interesting application is for the arts is the non-fungible token, the NFT. So we talked about cryptocurrencies, but NFTs are unique cryptographic tokens that exist on a blockchain. And this is the key part, they cannot be replicated. That's why they're called non-fungible. And this is used to verify ownership and authenticity and commonly associated with digital files such as digital art. Attacks are possible against NFTs. There could be phishing, there could be malware. So you could bring up cybersecurity attacks against NFTs in your arts classes. This is an example of a Bored Ape NFT from the I got the image from the New Yorker. I thought it was pretty cool. So the last topic, of course, there are more, but the last topic I'll be dealing with in cybersecurity and arts is generative AI. So one thing is generative AI, now researchers are discussing the idea of watermarking. I think big companies, Google, Apple, and so on, are talking about watermarking their generative AIs to mark which content has been AI generated, because they noticed people are using these images just generated from generative AI, and this might be harmful. So watermarking would basically be generative AI generates an image. They would have like a special marking here, watermark here, to show that it's been generated by a generative AI. There is also the concept of model poisoning, which I find super cool. This could be used in both good and bad ways. For example, Nightshade is a benevolent application of model poisoning, or at least the initial intention is good, and it resists the AI companies that use artists' work for model training without their permission by poisoning their AI models' training data. So what this means is that in machine learning, you have a data set, and the learning algorithm, there's a training algorithm that learns from this data set and creates a machine learning model. But a poisoning attack would poison this with a rogue data, and then the learning algorithm would not be able to classify things correctly, or generate things correctly, depending on the usage. So for example, this is from the paper of Nightshade of model poisoning attack. It's by Shan et al. 2023. But you see how dogs, after poisoning, are turned into a cat at the end of 1,000 poison samples. Car turns into a cow. Fantasy art turns into line art. Cubism turns into cartoons. So this is an example of how models can be poisoned, and yeah, misused by attackers as well. So moving on to the last field of application, cybersecurity and psychology. In AP Psychology Unit 5, you deal with cognitive psychology, and I think this is super relevant to the idea of actually a big field of cybersecurity called social engineering. Social engineering is when you try to psychologically manipulate people into performing actions or divulging confidential information that they should not be divulging. And phishing is a form of social engineering that you typically hear about, where attackers deceive people into revealing sensitive information or installing malware such as ransomware. It can be over email, it can be over phone. This is called phishing, over SMS, smishing. The right is an example of smishing that my research advisor got. The USPS package has arrived at the warehouse. And this can even be done via QR codes these days. And while you're talking about phishing, why do people fall for phishing? People say, oh, don't click on unknown links and everything, but why do people fall for phishing? One rationale, one reason could be the anchoring bias, in that the individual relies heavily on the first piece of information given to them when making a decision. For example, this would be the sender name, UPS, IRS. The USPS package has arrived. USPS anchoring bias, we see it and we typically associate it with, oh, it's the postal service. We don't think about checking the link, whether it seems legit, whether you have even ordered the package in the first place, whether what number it's coming from, and so on. So anchoring bias would be one way to explain why phishing still happens frequently today. Another thing that you could talk about in Unit 7 while talking about motivation is the concept of thinking like an adversary. So what are the motivations for adversaries in cybersecurity? Motivation is something that initiate, direct, and sustain behavior, and we can divide this into extrinsic motivation and intrinsic motivation. Motivation that is driven by an external reward or punishment, or a motivation that is driven more by internal factors. So when it comes to cyber examples, for hacking, there is the extrinsic motivation for hacking. Cyber criminals, this could be for financial gain. Bulk bounty, this could also be for financial gain or to improve yourself. That would be more of an internal motivation, right? Financial gain would be more of an extrinsic motivation. Nation state actors, their extrinsic motivation could be political agenda, like actually influencing election results. This could be their occupation, salary, fame. So this would be extrinsic motivations. Intrinsic motivation could be hacktivists. They could be driven by values. I don't agree with this value. So it could be hacktivist, it could just be for fun enjoyment. It could be a disgruntled employee who wants to express discontent at their company or previous company or other companies and so on. So what are some key takeaways from both videos that you saw? I hope, one, you realize that cybersecurity is an interdisciplinary field. While we typically talk about cybersecurity from a computer science perspective, it has a lot of math components. You can talk about it in government settings, government classes, economics classes, arts, psychology, and so on. Two, cybersecurity can be integrated into K-12 classrooms. You saw example mappings and also in some cases, example assignments of AP units or other high school curriculums with cybersecurity topics. Three, cybersecurity is interesting. I hope this workshop was interesting for you. And if so, please check out our future seminars and consider our in-person teacher camp in June. So these are some sources I utilized. And if you have any questions, comments, feel free to reach out to us at other@picoCTF.org. And thank you for your time again.